Today we're going to dive into a fascinating topic. We'll be exploring the concepts, working through examples, and taking a look at some cool real-world applications that you can relate to writing equivalent expressions. So let's get started. In math, we often encounter expressions that can be written in different ways, yet still represent the same value. By rewriting expressions in equivalent forms, we can simplify calculations, gain new insights, and solve problems more efficiently. This skill is essential in algebra and extends to various branches of mathematics. You might be wondering how these concepts apply to the real world. We can see them in video game design, where programmers often use mathematical expressions to model the behavior of objects or characters. In physics, we often need to rewrite expressions to better understand the relationships between variables. In finance, when managing personal finances, teenagers may need to rewrite expressions to determine the best way to save money or pay off debt. And in environmental science, here scientists study the impact of climate change on ecosystems and often use mathematical models to predict future conditions. Let's start with a simple example. Suppose we have the expression x squared minus 4. This expression can be factored into an equivalent form, x plus 2 times x minus 2. By rewriting the expression, we can easily find its roots, which are x equals to 2 and x equals to negative 2. Now, let's look at a quadratic equation. 3x squared minus 12x plus 12 is equal to 0. To solve this, we can rewrite the equation in its factored form. First, we can factor out a 3 from each term. 3 times x squared minus 4x plus 4 is equal to 0. Then, we can factor the quadratic expression further. 3 times x minus 2, and all that to the power of 2 equals 0. Now, we can easily see that x equals 2 is the only solution. Engineers are tasked with designing a bridge to span a river. The bridge must be both structurally sound and cost-effective. The load-bearing capacity of the bridge depends on the materials used, the bridge's length, and the distribution of weight across its surface. Engineers use mathematical expressions to model the strength and stability of the bridge. For instance, let's consider the expression F equals K times L squared divided by D, where F represents the force exerted on the bridge, K is a constant based on the materials used, L is the length of the bridge, and D is the depth of the supporting beams. In this scenario, the engineers want to determine the most cost-effective way to design the bridge while ensuring it can support the required weight. They can rewrite the expression in an equivalent form to solve for different variables, depending on the information they have and the constraints they need to meet. For example, if they need to minimize the cost of materials, they can rewrite the expression to solve for D equals K times L squared divided by F. This allows them to calculate the minimum depth of the supporting beams needed to support the force exerted on the bridge. Alternatively, if the engineers have a fixed budget and need to determine the maximum length the bridge can span, they can rewrite the expression to solve for L equals square root of F times D over K. This helps them find the longest possible bridge length that can be built within their budget constraints while still ensuring the bridge is strong enough to support the required force. In both cases, rewriting the expression in equivalent forms allows the engineers to make informed decisions about the design of the bridge. So, there you have it. Writing expressions in equivalent forms is not only an essential skill in mathematics but also a powerful tool for solving real-world problems. By practicing this skill, you'll be better equipped to tackle challenges in your everyday life and future career. Keep exploring math, and don't forget to have fun along the way.